In this integral, we are going to look at something called the Riemann sums. Essentially, it's the sum of all of our rectangles and the definite integral. So we'll start off with a definition. We'll let f be defined on the closed interval AB. And let change of x be a partition of that interval AB. Where change in x is the width of the kth interval, subinterval, I should say. And c sub k is some point in that interval. Okay, so that would give us, if we sum all that up, the sum from k equals 1 to n of f of c sub k times change in x, this is called the Riemann sum. Okay, and all of the sum that we looked at in the previous section, giving us the area under the curve, is a Riemann sum. And so I'm going to relate that to the definite integral. So if we take the limit, as long as we are taking the limit as n goes to infinity, then that sum from k equals 1 to n of f of c sub k times change in x is going to give us also our definite integral. So the integral from a to b of f of x dx. Okay, so there's a little bit of a difference between finding the area under the curve and evaluating a definite integral. First of all, finding the area under the curve, say in this case, we can find this area because all of this area is positive. Okay, so that's when we evaluated between 0 and 2. But for a definite integral, I don't have that requirement that f of x be positive, because for a definite integral, I could evaluate this function, say, from 0 to 3. And so what I would be calculating would be this area and this area. And a part of this area is going to be negative. It's going to negate some of this area. So for a definite integral, you could end up with some negative values. You can get a negative number evaluating a definite integral. So it doesn't require that you evaluate only positive values. And so this is our definite integral, where a is called the lower limit of integration, and b is called the upper limit of integration. Okay, So only requires that the function be continuous, not that it be positive. When you're calculating the area, you want positive values. But for a definite integral, you can calculate, and you can calculate this just based on the same way that you evaluated the Riemann sum.